parameters to measure the performance of steam boiler. Second question, solve one problem for the calculation of equivalent evaporation as well as thermal efficiency of the plant.
Performance of steam boiler is measured with the help of two parameters. First one is the equivalent evaporation and second one is the boiler efficiency. Now to understand the concept of equivalent evaporation, we will first understand what is the phase change process of water with the help of diagram. Consider piston cylinder arrangement. Now in this piston cylinder arrangement there is 1 kilogram of water at a temperature of 20 degrees Celsius and at atmospheric pressure. Now we will add the heat to this water. So throughout the process pressure will remain same, that is the atmospheric pressure. Then what will happen? So as we add the heat to this water, then the temperature will increase. Now this temperature will increase up to a boiling temperature of water. So we have to show this process. So we will show this process. The initial temperature of water is 20 degrees Celsius. On this vertical line we will plot temperature and on this horizontal line we will plot here the heat addition. So initial temperature of water is 20 degrees Celsius. As we add the heat, temperature will getting increased up to 100 degrees Celsius. So here is the 100 degrees Celsius. So we will show this process. So heat addition is also taking place. So we have to show this inclined line. Now what is the heat added? So heat added because the phase of this water remains same from this 20 degrees Celsius to this 100 degrees Celsius. So here the heat added is known as the sensible heat. So I will write here the heat added is known as sensible heat. Now we will move for the next. So 100 degrees Celsius is the boiling temperature of water at atmospheric pressure. So again if we continue to add the heat, then what will happen? So here the water starts to get converted into steam and the heat addition will be used to convert the water into steam, and at the final point whole water is getting converted into dry and saturated steam. So during this whole process temperature of water will remain same, that is 100 degrees Celsius. So we have to show this process. So temperature will remain same. So we have to draw here horizontal line. Now the heat added is used to change the phase. That is, during this heat addition process from this point to this point, here the phase change process is taking place. So this heat added is known as the latent heat. And here the process of evaporation is taking place. So this process is known as the process of evaporation. Now again if this dry and saturated steam again getting heated, then its temperature is getting increased. So this temperature of steam is getting increased, known as the superheated steam. So here we will show as the heat addition is taking place, temperature will also getting increased. So I will show this process with this line, and here this process is known as the superheating. So I will show this is the superheating. And the heat addition during this process is known as the superheated, or we can say superheat. So this heat is known as the superheat. Let us understand the concept of equivalent evaporation with the help of this diagram. Now here this heat addition process to the water is taking place at constant atmospheric pressure, and the boiling temperature of water is at 100 degrees Celsius at this given pressure. Now for the concept of equivalent evaporation, we have to consider this evaporation process in which the latent heat is included. Now how we will define this equivalent evaporation? So it is the amount of water evaporated from a feed water temperature at 100 degrees Celsius up to a dry and saturated steam at given atmospheric pressure that is equal to 1.013 bar. Now if we observe this diagram, here the evaporation process is taking place for the given atmospheric pressure. The feed water temperature is 100 degrees Celsius and this water is getting converted into dry and saturated steam. So suppose if I consider this point as A, then from this point A up to this point B, this process is taking place and the heat added is known as the latent heat. So how we will write the formula for the equivalent evaporation? So notation is capital E, which is equal to total heat required to evaporate feed water. So what is the heat required to evaporate feed water? That we have to take here in the numerator divided by 2257. Now what is this number? So this number is constant and fixed that we have to take to solve the numerical. So this latent heat of evaporation at atmospheric pressure 1.013 bar, which is equal to 2257 kilojoule per kilogram. So we have to take this number because this 2257, that is nothing but the latent heat of evaporation at 1.013 bar, that is at atmospheric pressure. So this is the formula to calculate the equivalent evaporation. Now we will move for the next. Now what is the total heat required to evaporate the 1 kilogram of feed water? So remember, here we have to take 1 kilogram of feed water. So the heat required to evaporate 1 kilogram of feed water, that we have to take the enthalpy difference. So enthalpy at point B. So suppose we will say H and enthalpy at point A, that is HF1. Now H is greater than HF1. So we have to take the difference H minus HF1. Now this H is for the dry and saturated steam. So suppose H point will be here, is in between A and B. Then we will say the steam is wet steam. Suppose this point is in between this point B and suppose here is the point C, that is for superheating. Then we will say that the steam is superheated steam. So how we will define this H for the dry and saturated steam, wet steam as well as superheated steam? So I will show here with different points. So for wet steam we will take here the point in between A and B. So I will say here the point P. Then for dry and saturated steam, so here is the point B is at the dry and saturated steam. And for superheated steam, I will say here the point as a Q. Then we have to define this H. Now from the steam table, how we will get the values? So when steam is wet steam, then at given pressure we have to find out the value of H. Suppose the point is in between A and B, then how we will find out? That is HF plus X into HFG. Now this HF and HFG values are given in the steam table and X is nothing but the dryness fraction. Now when there is the dry steam, that is when point is at B, then the enthalpy we have to take as a Hg. So Hg directly given in steam table, or we can also write HF plus HFG. So HF and HFG at given pressure, that we can find out from the steam table. Then for superheated steam. So now for the superheated steam, that is when suppose there is the point Q, then how we will find out this? So here we have to take Hg, that is the enthalpy at this point B, plus Cp, that is the specific heat of superheated steam, in the bracket temperature difference, that is T superheated minus T. So we will say that the temperature at this point Q is nothing but T superheated. And the temperature at this point B, or we can say temperature for this evaporation process, is nothing but temperature T. So we have to take the difference in between these two temperatures. So in this way we have to find out this value of H and we will take the difference. Now what is the value of HF1? So if we observe enthalpy at point A is nothing but HF1. So this is the sensible heat of feed water at T1 degree Celsius. So we know that here is the sensible heat. As the water is getting increased, here is the boiling point of water. So this boiling point of water is different at different pressure. So at atmospheric pressure it is 100 degrees Celsius. But when the pressure is getting differed, then this boiling temperature is also getting differed. So we have to take the boiling point of water, that is sensible heat of feed water at T1 degree Celsius. Then this is the formula for 1 kilogram of water. But when there is Me, that is the mass of water actually evaporated, so we will say M to the base E. Then what is the total heat required to evaporate Me kilogram of water? That is, we have to multiply with this mass Me, H minus HF1. So these are the important formulas that are useful to solve the problems. Now we will understand the second parameter, that is the boiler efficiency. So efficiency is the ratio of output by input. Now in boiler, output is measured in terms of steam produced. So we have to write, that is the output is equal to heat used in producing the steam, and input is heat supplied to the boiler. That means we can write heat liberated in the furnace. So we will say that boiler efficiency neta is equal to heat used in producing the steam divided by heat liberated in furnace. So what is the heat used in producing steam? So we know that during the process of evaporation that is taking place in the boiler, we have to take this enthalpy difference, that is H minus HF1 multiplied by the mass of water actually evaporated, that is Me, divided by heat liberated in the furnace, that is the calorific value of fuel that we have to take. Then Me, how we can define? That is, this is the mass of water actually evaporated. So we can take also in the form of Ms by Mf. Now what is this Ms? So this is the mass of water evaporated in steam, and divided by Mf, that is the mass of fuel used. So these are the formulas important to calculate the boiler efficiency. Now we will solve one problem with the help of steam table. I will read what is the given question. The following observations were made on a boiler plant during 1 hour test. Steam pressure 20 bar, steam temperature 260 degrees Celsius, steam generated 37,500 kilogram, temperature of water entering the economizer 15 degrees Celsius, fuel used 4,400 kilogram, energy of combustion of fuel 30,000 kilojoule per kilogram. Calculate equivalent evaporation per kilogram of fuel. Second, thermal efficiency of the plant. So this was the given question. Let us first understand the given data. Now steam pressure is given 20 bar. Now if we observe in the boiler, evaporation process is taking place at constant pressure, and that pressure is given at 20 bar. So we can say that this process of evaporation is taking place at 20 bar pressure. We will give here the notation as a P. Then at this pressure P, with the help of steam table, we can find out what is the enthalpy of dry and saturated steam, that is Hg. So this enthalpy at point B. So at point B there is the dry and saturated steam. So we will say here is the enthalpy Hg that we will find out. So here is the saturated water and steam pressure table. So in the first column pressure is given. So for 20 bar pressure we have to find out the value of Hg. So here we will write Hg is equal to 2797 kilojoule per kilogram. Now at this pressure, we will also find out the temperature. So temperature is also given in the second column. So temperature T is equal to 212 degrees Celsius. Now steam temperature is given. So here in the boiler, when we measure the steam temperature, then it is 260 degrees Celsius. Now if we compare what is the saturated temperature at 20 bar, it is 212. But actual steam temperature is more than the saturated temperature. So this 260 degrees Celsius, we will say that this is the superheated steam, because this temperature is more than the saturated temperature at the given pressure. So here this steam is the superheated steam, so we will say that the steam will be at point C. So the temperature of 260 degrees Celsius, that means here is T superheated. That we have to write. Then steam generated. So steam generated 37,500 kilograms. So this is the mass of steam generated given. So we will say that this is MS. Then fuel used 4,400 kilograms. So this is the mass of fuel used given. So we will say MF. So what is the mass of water actually evaporated? So we have already seen that. So I will write from this, we will say mass of water actually evaporated, that is equal to ME. So ME is equal to MS by MF. MS by MF, that is equal to 37,500 by 4,400, and which is equal to 8.52 kilogram per kilogram of fuel. So this is the value of ME that we have to use in the formula. Then the temperature of water entering the economizer. So when the water is entering the economizer, that is for the evaporation process, then we can say that this is the feed water temperature. So this is 15 degrees Celsius is nothing but the feed water temperature. So this 15 degrees Celsius I will plot here as a T1. So at this feed water temperature, we have to find out what is the value of enthalpy. So enthalpy at this feed water temperature is nothing but HF1. So if we observe here, we have to find out the value of HF1. So we can also find out this value with the help of steam table. So we have to refer here the temperature table. So temperature, that is for 15 degrees Celsius. So in the first column temperature is given, and we have to find out value of HF, that is 62.9. So we will say HF1 is equal to 62.9 kilojoule per kilogram. Now energy of combustion is given 30,000 kilojoule per kilogram. So we will say C, that is the value of C is given. Now in this case, if we observe, the steam is the superheated steam. So what is the enthalpy of this superheated steam? That is nothing but H superheated. So if we refer here, this temperature T superheated is at point C, then with reference to this point C, here we will show that the enthalpy is H superheated. Now we will move for the calculation part. We will first calculate what is the enthalpy at this point C, that is enthalpy for the superheated steam. So how to calculate the enthalpy of 1 kilogram of superheated steam? So here we have to refer the enthalpy of dry and saturated steam Hg at given pressure 20 bar. Then we have to refer temperature of superheated steam, that is actually given T superheated, that we have to refer, and also we have to refer the temperature, that is the saturated temperature at 20 bar pressure. So that we have to take. So Hg plus Cp. Cp is the specific heat. So this is not given in the question. So specific heat of superheated steam we will take here 2.1 kilojoule per kilogram. T superheated minus T. So Hg that we have already seen at 20 bar, it is 2797 plus Cp 2.1, T superheated that is given in the question 260 degrees Celsius minus temperature that is saturated temperature at 20 bar, because this process of the superheating or evaporation is taking place at constant pressure, that is 20 bar. So we have to take the temperature here as a 20 bar. So 212. So what is the answer? 2897 kilojoule per kilogram. So we will mention here this. Here is the enthalpy H superheated, and here is the enthalpy for the feed water temperature, that is at a temperature of 15 degrees Celsius, it is HF1. Now what is the first question? To calculate the equivalent evaporation. So we have formula Me, that is the mass of water actually evaporated. So we have already calculated in the bracket H superheated minus HF1. So here is H superheated minus HF1 divided by 2257. So 8.52 in the bracket 2897 minus 62.9 divided by 2257, which is equal to 10.7 kilogram per kilogram of fluid. So this is the equivalent evaporation. Now we will move for the next. Thermal efficiency. So what is this thermal efficiency? That is, again we have formula Me H superheated minus HF1 divided by C. So C is nothing but the energy in the combustion of the fuel. So here 8.52 in the bracket 2897 minus 62.9 divided by 30,000, which is equal to 0.805. But here efficiency is there, so we will take this into percentage. So we will multiply here with 100, and which is equal to 80.5%.